The steps you'll notice are the exact same as yesterday. So, if you've got these written down, not if, you should have these in your notebook from yesterday. I just want to stress that the only way to separate the variables is by multiplication or division. And again, you want x's on one side, y's on the other. Then step 2, of course, is to integrate both sides, find the constant, and then solve the differential equation of the variable that appears in the numerator of the differential equation. All right, so let's attack our first problem. Find the particular solution to y equals f of x, the given differential equation with initial condition f of 2 equals 0, for dy dx equals 2y minus 1 over x cubed. All right, so again, I just want to stress that this is like saying the point 2, 0 is on the curve f of x. So that's clearly my x, and this is clearly my y on this function. So same rules as yesterday. You're going to start by cross-multiplying. I've got x cubed dy equals, and I'm going to use parentheses, that's the quantity 2 minus 1 dx. Okay, and it's important that you put those parentheses there because you can only multiply or divide. Now at this point, you've got to ask yourself, are your variables separated? Well, you've got x's and y's here and x's and y's here, so that answer is no. So I have to get the y's on one side, x's on the other, and again, I just want to make a note here that your dy and dx must be in the numerator. Okay, it's not an option. They're not separated if dy and dx are not in the numerator. So I'm going to divide over the x cubed to both sides, okay, because I cannot divide the dx over, and I'm also going to divide over the 2y minus 1. So what does that leave me with? I've got dy over the quantity 2y minus 1 equals dx over the quantity x cubed. Okay, so at this point in time, I would say we are officially separated. I only have y's on one side, only x's on the other side, and the dy dx's are on top in the numerator. So now I can integrate both sides. Okay, so just slap your integral around both sides. All right, so as I check these out, I think one side's a lot nicer than the other. And I'm hoping you're thinking the right side's a little nicer. Again, there is no quotient rule. So on this right side, I'm just going to bring the x cubed up by saying it's x to the negative third times dx. Now, I can't do that on this side. I don't want to say it's this junk to the negative 1. Okay, I only want to do that if I have a single term like I had on the right side here. So I'm just going to leave it as it is. dy over the quantity 2y minus 1. And like I said, 99% of these, I believe I said this yesterday several times, are going to involve u sub, which of course is what we're getting on this right or left-hand side. So I'm going to do the easy one first, which is the right side. I'm going to integrate this. I'm going to add 1. So I'm going to get x to the negative 2 divided by negative 2, and the x gets the plus c. Now I'm going to take my pretty old time here on the left. This is definitely, if I were to take the derivative, it would be quotient rule. So I'm going to use u sub. My u is 2y minus 1 du equals 2 dy. So I get du over 2 equals dy. Okay, now again, I just want to stress, I have not integrated, so leave the integral symbol there. I'm getting du over 2, and I still have on the bottom my u. Okay, so basically I'm replacing this dy. I can pull the dy over here if I want, so that's du over 2 over u. So I have not integrated. I'm pulling out the 1/2, and I've got du over u equals, this side was integrated, x to the negative 2 over negative 2 plus c. Okay, so now I have to integrate. Who are you staring at here? And that's the million-dollar question. You're going to see this so many times in the next few days. When you see du over u, if you want to think of it as u to the negative 1 and integrate, you end up getting u to the 0 over 0, which is impossible. So that means that somebody's special. Okay, and that's the derivative, of course, of ln. So I'm getting the ln of the absolute value of u equals x to the negative 2 over negative 2 plus c. Now, I'm going to clean this up a little more before I attempt to solve for c. I'm going to say I have the ln of the absolute value. Who was my u? If I just scroll back up here, u was 2y minus 1. And I'm going to say that's all that junk over 2, really 1/2 times that, equals, I'm going to move this x squared here to the bottom, of course. So I'm going to say that's 1 over negative 2x squared plus c. Okay, and let's go ahead and box that in. We've officially integrated and separated the variables. And now my job is to go get that value of c. Let's just recall the initial condition. I believe it was f of 2 equals 0. So again, x is 2, y is 0. So I'm going to get the ln of the absolute value of negative 1 all over 2 equals 1 over, it's going to be negative 8 plus c. Alright, so solving for c, just going to keep continuing here. The absolute value of negative 1 here is really the ln of 1 all over 2 equals negative 1/8 plus c. Okay, and this is why we have you draw those ln graphs over and over on the fun quizzes or the bite-sized quizzes. Picture ln. What's the only value you have to know? And that's the ln of 1. The ln of 1 is 0. And 0 divided by 2 is 0. So I get 0 equals negative 1/8 plus c. Therefore, of course, c equals 1/8. Now, we're not done. All we did was get c. We need to take that c value and substitute it back into our equation and solve for y. So if I scroll back down, I've got the ln of 2y minus 1, absolute value of that, over 2 equals 1 over negative 2x squared. And now instead of c, I'm going to put plus 1/8. Alright, now this is where it gets a little more exciting when we have ln's involved. So I'm going to do the normal. I'm going to multiply everybody I see by 2 to get rid of this 2 here, of course. And remember, just do it to every term. So those kill there, and I've got the ln of the absolute value of 2y minus 1 equals negative 1 over x squared plus 1/4. If I kill that one as well. Alright, so here's the big deal. This is what's different from yesterday. So let's put a big star in our notebook. You are in log form. Okay, which means you need to convert to exponential form. Alright, so this is just straight up algebra 2 trig. You're in log form, you need to convert to exponential form. So here's the deal. You can put your base e in there. Remember, when you have ln's, you deal with base e. And to convert, you begin with the base. So again, I just want to make a note, begin with the base. So I'm going to draw a little arrow around it. It's e to this junk equals this junk. Okay, so it goes in a big circle. It starts with the base, and it goes to the outside equals the inside. So I'm going to say, I can rewrite this as e, go out to the outside there, to the negative 1 over x squared plus 1/4 equals the absolute value of 2y minus 1. Okay, so it's just changing from log form to exponential form. Our second big obstacle in these ln problems is to decide whether this absolute value is positive or negative. Okay, and the way to think about that is basically you need to go back to when you solved for c, when we took the ln of negative 1, and ask yourself, did that change my outcome? Well, if it was negative, that means it changed to a positive, which means it affects my outcome. So I have to put this negative back in here. Okay, so I'm going to say I have e to the negative 1 over x squared plus 1/4 equals negative times the quantity 2y minus 1. So if I keep solving, e to the negative 1 over x squared plus 1/4 equals negative 2y plus 1. And remember, my goal here is just to solve for y, so I'm going to subtract the 1 over. Minus 1. Notice that minus 1 is not in the exponent. And then I just want to divide everything I see by negative 2. And remember, just be fair. I've got a lot of terms here. Each term gets divided by negative 2. So basically, I'm going to get y equals e to the negative 1 over x squared plus 1/4 divided by negative 2 plus 1/2. Oops, that should be negative e to that junk plus 1/2. And I have officially solved this separable differential equation. All right, our second example. Find the particular solution to the given differential equation. Here's my initial condition, so that's implying when x is negative 2, y is equal to 1, to this equation here. Now, who do I want to solve for in the end? Look at the numerator, and it says dy. So again, I want to solve for y in the end. All right, so just like normal, nice easy cross multiply. E to the 4y dy equals the quantity x plus 2 dx. All right, quick check. Are you separated yet, or do you have more work to do? Well, this happens to be real nice. We're already separated. E to the 4y dy equals the integral of the quantity x plus 2 dx. All right, integrate both sides. I think the right side's easier. I'm going to start there. That just gets me x squared over 2 plus 2x plus c. Okay, this right side, the derivative, okay, is chain rule. E to the u du is chain rule, so I need u sub. Now, if you can do u sub in your head by now, which hopefully, 80% of us can, go for it. But let's write it out. If that answer didn't jump at you, you should be writing out your u sub. U to the 4y, u equals 4 times y. Du equals 4 dy, so I get du over 4 equals dy. Okay, so again, have not integrated, keep your integral symbol. E to the u, and in place of dy, I'm putting du over 4. So I can pull out a 1/4, have not integrated, keep the integral, e to the u du. This side is integrated, so I don't need to worry about the integral. Okay. Now, e's happen to be one of the easiest integrals and derivatives. The integral of the u is e to the u. So I've got 1/4 e to the u equals x squared over 2 plus 2x plus c. And of course, I want to plug in my u, which was 4y, equals x squared over 2 plus 2x plus c. All right, my goal is to get that y by itself, so to get rid of the 1/4, I'm going to multiply everybody I see by 4. So I've got e to the 4y equals, that's going to get me 2x squared plus 8x plus 4c. And whoops, I already forgot about my initial condition. I'm going to go and grab that because I don't want to solve for y yet. My initial condition, I believe, was negative 2, 1. So I'm going to get e to the 4th. Negative 2 squared is 4 times 2. That's going to get me 8 minus 16 plus 4c. So I've got e to the 4th equals negative 8 plus 4c. Keep solving for c. E to the 4th plus 8 divided by 4 equals c. Now, of course, as long as you want to, clean that up a little, just make sure you make like a beaver and split. So e to the 4th over 4 plus 2 equals c. Okay. At this point, I need to take that answer and substitute it back into my equation. So I guess I'm going to substitute it into this one here. So I've got e to the 4y equals 2x squared plus 8x plus 4 times my c value, which is e to the 4th over 4 plus 2. So if I keep cleaning, e to the 4y, I've got 2x squared plus 8x whoops, I think I got an extra 8 in here. I'm going to kill this 8. I think that was extra. Not sure where that came from. Plus 8 plus e to the 4th. Sorry about that. Okay, now this is kind of the complete opposite from what we just had. I now want to go backwards, and I'm in exponential form. I want to convert this to logarithmic form. Okay, so I'm in exponential going to log. And I'm going to use natural log. Sorry about that. So I'm going to say ln, okay, it's always base, and then to what you're equal to, and then the exponent. So again, this is straight from Algebra 2. So I'm going to say ln, the base is e, of 2x squared plus 8x plus 8 plus e to the 4th equals 4y. And then lastly, to solve for y, I'm just going to divide both sides by 4. So I've got y equals, and you can either pull it out as 1/4 or you can leave it under there, the ln of 2x squared plus 8x plus 8 plus e to the 4th. Now, you'll notice I didn't put the base e in there. I mean, it's just assumed that you understand when you see an ln, there's an automatic base e. But again, if you want to put it there to make yourself feel a little better, by all means, go ahead. Well, we've tackled 2 examples tonight, and I think the biggest challenge for us is just going to be converting from exponential to log and log to exponential. So, just review those 2 facts. They're going to be used in most of the problems, I would say, and we'll see you tomorrow.